Hi there, this is Forces Lesson 3, and this one is contact and non-contact forces. It's quite wordy, this one. There's not much calculations to do apart from a starter question, so you might want to take quite a few notes. Or you can just watch this video a couple of times and, it'll sink in over time. Some of it should be familiar, little bits of it I'll have to explain a little bit more. So the objectives are to recall examples of contact forces, to recall examples of non-contact forces, and to have an understanding of what a normal reaction force is. All right, so remember these. So if you want to start with these, if you want to pause and have a go at those and calculate the resultant force. And when you're ready, just press play if you want the answers. So on this first one, we've obviously got the 10 newtons to the right, and then we've got a 6 newton and a 2 newton to the left, so that's a total to the left of 8 newtons. Now, because these are acting in opposite directions, we've got 10 to the right and 8 to the left. The resultant would be 2 newtons to the right. This one's a little bit more complex, so we've got 4 and 2 newtons to the right, so that equals 6. So now horizontally we've got 6 to the right and 6 to the left, so that resultant force horizontally is 0. They would cancel each other out. Then we've just got the 4 newtons up and the 2 newtons down. So 4 minus 2 would leave 2 newtons going upwards. The final one, so we've got a 12 and a 5 to the right. So that's 17 newtons to the right. To the left this time, we've got 7 and 6. So to the left we've got 13 newtons. Upwards we've got the 5 and 6, so that gives us an upward force of 11 newtons. And then obviously the downward force of 4 newtons. So let's solve this one. So we've got 11 up and 4 down. So that leaves us with a total of 7 upwards. 7 newtons. And then 17 to the right and 13 to the left leaves us with 4 newtons to the right, which is something like this. So what you can do to get the resultant force, depending on how much detail you want to go into, you could have done a scale drawing, so maybe a 4 centimetre line horizontal and a 7 centimetre line vertical, and then put your ruler on and obviously draw the line and then measure it to get an answer. Or you could just use Pythagoras. So if you do the scale drawing, you should have gotten around 8.1 newtons. And if you got that, that's really impressive, well done. And then you could have gone another step further with your scale drawing and got an angle. Or if you may be revising in year 10 or 11, you could calculate the angle using trigonometry. Either way, you should get an angle that is approximately 60 degrees. So the angles from the horizontal, from the 4 newton vector, is approximately 60 degrees. Hopefully that went okay. If you want to have another go at that, just rewind it and have another go. But apart from that, let's move on. So forces are, push or pull, and forces can cause an object to either speed up or accelerate, slow down or decelerate, change direction, or change shape. So force is measured in newtons, which you probably already know. We measure it with a newton meter, and there's some examples of some newton meters that you may have seen at school. Remember, if you want to make any notes at any time, just pause the video. So some types of force, so maybe a bit of writing on this one. So we've got gravitational, which we'll do later. So gravitational force is the attractive force between bodies because of their mass. Mass being what you might measure in kilograms. Mass is like the amount of stuff. So the force increases, you get more force if the masses are bigger or if they're closer together. And you'll experience this on Earth, as weight. So that's the gravitational force that acts on you or on other objects in your day-to-day life. So bathroom scales measure weight. A mass of 1 kilogram weighs approximately 10 newtons. You might be familiar with a stone. A stone's about 63 newtons. Obviously, we'll do that when we do gravity in more detail. Normal reaction or contact. So this is the repulsive force that stops two touching bodies moving into each other. And the word normal means that the force acts at 90 degrees, so it'll make more sense when we do this. So, for example, you've got the weight of this car. So the car's weight is acting, through the floor, and it's stopped by the floor. And there's two, well, in this picture there's two, but in real life you've got 4 wheels, so there'll be 4 contact points. But in this image there's two normal reaction forces. And they're called reaction forces because they're reacting to the weight pulling it down. And also they're called normal because, as it says, the forces act at 90 degrees to the surface. So the surface is obviously the surface of the road, and as you can see, that force acting upwards is acting at a 90-degree angle. Alright, both of these. Hopefully that's clear. Another example, so if the weight of the car, I don't know, maybe, let's just say 8,000 newtons, say it's a light car. How much force do you think could be acting in total going up, and then how much should be acting on the 2 wheels in the image? Well, the total force acting up must be equal to 8,000 newtons. Hopefully you could think of that one. It should be the same. And if there's 2 contact points, each contact point you would expect in this image to be, approximately 4,000 newtons each. If there's 4 wheels, if it's a real car, then obviously each wheel would have 2,000 newtons each. And you do more of this when you do resultant forces, Newton's second law, F equals ma. But we'll come to that in a few videos' time. Hopefully that makes sense. So if you want to pause and make some notes, just please feel free to do so. Let's move on. So friction, this is the force that opposes motion. So a really good way to do that, you can just do it in your house on your own, is to put your hands together and just rub them quite frantically, and you'll feel the effects of friction. Your hands will warm up pretty rapidly. If you do it enough, they will actually get quite significantly hot. So be careful. The friction's needed. Friction's really important. It's needed for racing cars, not just racing cars, any type of car. Friction, that's the contact force between your feet and and the pavement, and ice or snow can be particularly hazardous as the friction, the amount of friction is reduced drastically. So you've got to be careful. Another one that you might have heard of, air resistance or drag. So it's the force that opposes the movement of objects through the air. It is not wind. Don't get it confused with wind. The way you might have seen it, say if you're in a car, with an adult, parent or a grandparent, guardian, you might have experienced drag on a motorway, for example. I remember doing this when I was younger. So if you're driving down the motorway, you've got the window open, and you put your hand up, and you'll feel the the resistance of the air hitting your hand. And when you're younger, you might have thought that as wind, but obviously now you know better. It's definitely not wind. It's just the resistance of the air. So drag is a more general term used for opposition force in any gas or liquid. And what we can do, a thing that comes up in exams, is how do we reduce drag, and we reduce drag by streamlining. So an example might be it's kind of sports car. I'm not sure what car this is. It looks a bit Aston Martin-esque. It's streamlined, and the reason the streamlined is so that to reduce drag, to reduce the amount of air that's hitting the car head on. And sometimes you might want to increase drag. If you've jumped out of an aeroplane, you'll want a parachute, and you'll want as much drag force as possible to help decelerate you or slow you down. Upthrust. So upthrust is the force experienced by objects when they're placed in a fluid. So maybe something floating on water, maybe a boat, or maybe yourself, on a dinghy or something, or a lilo in a pool, or in this case a hot air balloon. So a fluid is a liquid or a gas. It's basically a reaction force, but reaction forces are only on solids. So if you in an exam, if you're thinking this might be a reaction force, if it's in a fluid, a liquid or a gas, it's upthrust. Magnetic force is really basic, is, forces between magnets. If you push, magnets together, they'll either, they'll attract or repel. In electrostatic, they're your positive and negative charges. If you bring 2 positives together, they'll repel. If you bring a negative and a positive together, they'll attract. Okay. So that's just a brief overview of examples of contact and non-contact forces. The magnetic and electrostatic are significant examples of non-contact forces. I'll even write that. Non-contact. Alright, so choose appropriate words to fill in the gap below. This is closed exercise. It's just to You know, you can make some notes if you want, or you can just write 1, 2, 3, 4, 5, 6, or you can write numbers 1 to 8 and just put a keyword that you think. Now, if you want to have a go at it properly, you can pause now without any help. If you want to leave it a few more seconds, I'll put some keywords on. There you go. And then you want to pause and answer the question, and then I'll go through the answers. So to consolidate, a force is a push or a pull. A force can cause an object to accelerate or change shape. We said accelerate earlier, speed up or slow down. Remember, the opposite of acceleration is deceleration, which will be slowing down. Force is measured in newtons, and we can measure forces using newton meters. You might have seen them at school. There are many types of force. So contact forces. A contact force occurs when two bodies touch each other. Friction is a force that opposes the motion of one body relative to another, and it's caused by the attractive forces between molecules. So hopefully that's given you a brief understanding of contact and non-contact forces. So thanks for watching. I hope you found that helpful, and I'll see you at the next video.